In the previous video, we have seen the theory of text classification, the different steps that are involved in text classification, but now we will focus on the practical. So as you can see here, I will be doing some basic inputs, pandas, matplotlib, word cloud. Okay. So word cloud, as you all know, will be used for the visualization purpose. And after that, we'll be using TF-IDF and the count vectorizer for the vectorization purpose. So the data that I'm reading, the file is spam.csv. You can see, just a second. Yeah. So as you can see, the shape of this particular data set, it has 5,572 rows and 2 columns. So let me show you the data. So we have 5,572 message, and each and every message is labeled as either spam or not spam. Okay. So there are 2 columns. One is the message column and the other one is the category column. All right. Message column is all the messages and category is the label that is either spam or not spam. So now we have to develop a machine learning algorithm which will predict whether a given message is spam or not. First of all, we will do some visualization. So first thing that we are doing here right now is to get all the spam messages. As you can see, I am using conditional filtering to get all the spam messages, and I'm joining all the messages together, and we are generating the word cloud. You guys have already seen the code for the word cloud generation, and uh, yeah, so this is the plot. So the kind of words that repeat a lot in the message, in the spam message, the number one is the free. The term free in capital letters. As you can see, this repeats a lot in the spam messages. And apart from that, we have call, text, and some of the other words. We would like to do the same thing for the non-spam SMS. And as you can see here, I'm joining all the non-spam SMS, and then we are generating the word cloud. So the word that appears a lot is the word U. Sorry, is the letter U. Okay, and will. All right. So that's a little bit of data visualization for the spam and the not spam messages. Now the next step will be the text pre-processing. So the first thing that we will do is we will split the data and we'll split the feature and the target. So X, that is the message, and Y, which is the target, is the category. If you look into the target, it is actually in the form of object. So we have to convert that into number. So that's why we are using the label encoder object here to convert the target into numbers. Okay, guys. So we have split the data, target and feature. Okay, feature and target, and the target has been label encoded to 0 1. Okay, 0 represents not spam, and 1 represents spam. After that, obviously, we need to split the data into train and test. So that's why we are importing the train test split, and we are splitting the data into train and test, right? As you can see here, X train, X test, Y train, and Y test. Done. Okay, the basic steps are done. Now, the most important step, that is, we have to do a set of pre-processing. That is, we have to do tokenization. We have to remove the stop words, and we also have to do vectorization. But let me tell you that one vectorization step itself is capable of performing tokenization, stop word removal, as well as vectorization. So as you can see here, we are creating an object of count vectorizer. We have mentioned the stop words equal to English. So what this count vectorizer object will do, it will perform tokenization. It will remove the stop words, okay, English stop words, and then it will also perform the count vectorization. So using this object, we are calling fit transform on the training data and only transform on the testing data. Okay. Now I would like to show you something. Now, if you want to see how your data looks like, you can print Xtrain, Xtrain CV. So it will show you something like this. That means you're not able to print the data. Okay, you're not able to print the data after converting it into count vectorizer. Okay, after converting it using count vectorizer, you cannot directly print it. But if you really want to see, you can convert this to an array. So you can see two array. So it's a huge data. So obviously not every value is visible. But you know what? It is not compulsory to see the data. Okay, it is not compulsory to see the data. I can actually directly pass this xtrain CV object in machine learning. Okay, this object can be directly passed into machine learning. So the machine learning algorithm that I'm using is the decision tree classifier, and we are also importing the classification report. Here we create the decision tree classifier object. We pass xtrain CV, ytrain. Okay, fit function is done, and then you will call the predict function on the testing data, and we will print the classification report. So as you guys can see, the classification report, it's a great score, 97% accuracy. Okay, and you can also individually check the recall and the precision and the F1 score. Everything seems nice. Everything seems good. But anyways, we should also try the TF-IDF vectorizer. And to be honest, the steps are exactly same. The only difference is here you will create an object of TF-IDF vectorizer. Stop word equal to English. So again, this will also perform everything. Okay. Vectorization, sorry, tokenization, stop word removal, and vectorization. Calling fit transform on the training data and transform function on the testing data. Creating decision tree object, calling the fit function, we are passing xtrain, tf, and ytrain, and then we're gonna call the predict function, and we will print the classification report. So as you can see here, the scores are almost similar. In fact, the recall of one is slightly lower here. Previously, the recall of one was 88%, but right now it is slightly lower. But yeah, doesn't really matter. Like the score, the difference is not that much. So both TF-IDF and count vectorizer both are giving us good result. So this is the practical of text classification using machine learning. In the next video, we will see how to do the same using neural networks.